The problem that we're looking at today is the USACO 2021 December contest gold problem 2 of HILO. And this is a really good problem and I really like it. So I strongly suggest watching this whole video and then even looking at the code that we'll be posting in the comments below, because this is a very good problem for thinking and it'll help you a lot in all types of USACO problems. So first of all, you can pause the video and read the problem yourself. Alright, despite the lengthy problem description, the thing that you're being asked is actually quite simple. So basically, you're in a game right now where you're there's a guesser and there's two persons. Now one person has a number X, and now the other person choose a permutation of a bunch of numbers from 1 to n, and each time the guesser, which is the person with the permutation, asks the number in this permutation, and the person with the number tells them whether this number is too high or too low. So if it's high or if it's low. And then after each number is asked, if it's high, if it's too high, well then we never ask this, we never ask any number above this one anymore. And if it's already low, we never ask any number below it anymore. So we just skip any further number that's below it. And you're trying to determine how many, like if you record down all the highs and lows it said, how many high lows will be formed in this sequence. So basically, let's say we have this permutation and say the number that we're being asked is 3, right? So first we ask 5, and 5 is obviously too high, so the first thing is high, right? And then that's why the first is high. And then second is 1, since x is 3, 1 is too low, so we say low. And then 2 is also too low, right? And then 4 is high, is greater than 3, and then 3 is low. And it's because it's equal, and it's equal, we say low. And now we're trying to determine how many high lows there are, and we notice that there's 2 of them. High low, right? And now you have this permutation, but you don't have the number x. And you're trying to determine for each x how many high lows will be said. And n is at most 2 times 10 to the 5th power, suggesting a linear or n log n complexity solution. Then you can pause the video first and see if you can figure this out on your own. Alright, so how do we solve this problem? First of all, I have to say this is pretty difficult and you have to think a lot before you start writing the code. And after you actually figure the solution out, the code is really, really simple. It's just the thinking process that's actually hard. So first of all, noticing the size of the n, the first thing that we notice is that we definitely cannot enumerate every x. That will only work for test 1 through 4, because that allows n squared complexity. Because if we test every single x, we have to at least go through all of the n for every x, and it's going to have a time complexity of at least n squared, which is unacceptable. So the only thing we can do here is to, for each spot, consider how many x it will contribute to. So to how many different x will this spot contribute to forming a high-low, right? That's just the typical trick for problems like this where you can't enumerate through every x. You consider the contribution to different x's on each spot. And now we have 2 ways of considering this. Either for each spot, we consider how many high lows it form while this spot, say I, form the high of the high-low. Or another way is consider like how many x does this I form the low of the high-low for this x. All right. And now we realize that it's actually way easier if we do the second method. So first of all, let me tell you what I mean here by 2. So say I'm just going to indicate the size of the number with the height of these poles. All right. And I have all these numbers in the permutation. All right. And now the 2 options that I was saying earlier is, so say we have an I right here, right? And now, since we can't enumerate through every single x, we have 2 options of either considering for how many different x's will this I form a high in the high-low pair, and for how many different x's will it form a low in the high-low pair. And we realize that doing a low is way easier. Because why? Because we realize that in order for a high-low to be formed, we first consider for what different j can be the high of this high-low for this I, right? And then we realize that this j can only be one certain value, and that is out of every single I minus 1 value that came before I, the first one to be greater than AI. The first j to have aj greater than AI. So basically put all these greater values into a sorted list and then basically binary search the first value greater than AI. Why is that? Because let's think about it. Every time we ask a query, we basically divide out half of the numbers. say we ask this one, either from now on we never ask any numbers below it again because we said this number is too low and we skip all of those, or from now on we never do any numbers above it again because maybe this one is too high and we skipped everyone above it, right? And now we realize that if we want a j to form high-low with this I and have j be the high without skipping either I or j, there cannot be any poles of height between j and I between them, either before j, after j, or it can be after I. After I, we don't care. Right now, I is like the ending point, right? And there cannot be any poles of height between the height of I and the height of j, because after we come across this pole, we divide out half the things. So if this pole came between the location of I or j, well then we either don't get to do I anymore or we don't get to do j anymore. Or if this pole came before j, obviously one of them is going to be cut out. We don't get to ask both of them. One of them have to be skipped if the j that we're wanting to use to high-low is not the first one to be greater than ai. So knowing this, we know that there's only one possible j that can form the high of the high-low with I. How do we determine if it actually forms it? How do we know if this j actually form a high-low with this I? Well, let's consider what are some situations that this possibly might not happen. Well, the first possible thing is that we don't get to do both I and j. Like one of them is skipped, and we know that can only happen if, obviously, if there is a pole of height between I and j. In this case, there is one. That'll be either this pole or this pole, which will cause one I or j to be skipped, right? So in the presence of one of these poles with height aj between ai and aj, obviously it doesn't work. But we already know that aj is the first one to have height greater than ai. So in this case, j, instead of being this one, j should actually be this one, because that's the first one with height greater than aj, greater than ai, obviously. And now that we already eliminated the case in which one of them is skipped, there's still one more situation in which we don't form a high-low, and that is when there are some poles between them that we cannot skip, right? Because now think about it, if we have some poles between them, we don't actually care if these poles form a high-low with I, because we'll calculate them later, obviously. And now if there's poles that we can't skip, obviously j and I doesn't form high-low. And how do we know if every single pole in the middle of ij can be skipped? Well, obviously we can't enumerate through all of them, because that'll give us an n-squared time complexity. Now we realize that the only case in which a pole is not skipped is actually the case in which the first pole with height less than I is between I and j. You can try to prove that yourself, but I'm just going to explain why that is here. So first of all, if there's any pole of height greater than j, say those two poles in the middle are great examples, we know that they're for certain going to be skipped. Because first of all, we already know the x's that this pair ij is going to contribute to for high-low, the x is going to be in between this range, right? Because if it exceeded, it's either going to be high or low, right? So it's going to be in this range. And since x is in this range, and since j is already high for this x, well then both of these poles are certainly going to be skipped. So we know that the upper bound of a pole that cannot be skipped between ij is the length of j. And there's also a lower bound, and that lower bound is the height of the first pole with height lower than I. And by the way, I is the lower one of the pair I and j, all right? And why is that? Because when we pass by this lower bound, say this lower bound came before j, all right? Say that. Okay, I'm going to use a different color because this is getting really confusing. So say this is the first one with height below I. Well, since we already know that x is between I and j, since this pole has height below I, everything with height below this pole is going to be skipped. So say if we have another really short pole in the middle, then obviously it's going to be skipped, because this thing, after we pass this smaller pole is basically filtered out, right? So knowing this, now we have an even smaller range for a possible pole that might not be skipped. And now I'm going to use a different color once again. It's going to be up to from j to the first pole that's shorter than I, and which is right here, right? And now, since we already know there's nothing present between I and j, because j is the first one with height greater than I, and there's also nothing present between I and the first pole with height shorter than itself, which let's call this pole, say, k, all right? There's nothing between I and k because k is the first one with height shorter than I. So we know that both of these regions are empty. Well, then what's the only possible case that will block I and J from forming a high-low is when K itself is in the region between I and J. So you see how we got here? How we basically ruled out all the options, eliminated all possibilities, and leaving us with only one possible option is when K is in the middle of I and J. And that's the only possible situation in which I and J doesn't form a high-low. And that's all there is. It's just as simple as that. And when we're writing the code, we basically just find the first spot with high greater than this spot and the first one with high lower than it, and then we're done. We just check whether the first one with high lower than it is between this current one and the first one with high higher than it. That's all we check. And if there is, then we use a prefix sum to add the answer to the x's that it contribute to, which obviously is going to be the x's with size between AI and AJ. And that's all there is. It's as simple as that. So we just spent like a bit over 10 minutes explaining this whole problem, and the code comes down to be this simple. It's just the end log n code. The only complicated, I wouldn't even call it an algorithm part, is using a set to find fs and fb, meaning the first smaller and the first bigger. And that's all we need to do. And we just check whether the first one that's smaller than it occurs after the first one that's bigger than it. All right. So I hope you don't even need to look at the code. If I've explained it clear enough in the video, I hope you don't even need to look at the code because of how simple it is. But I'm still going to be posting it down in the comments. And hopefully after this video, you know how to solve the USACO 2021 December contest gold problem 2 of HILO. And it's a really, really good thinking problem as we just keep exploring more possibilities until we finally find that the code and the answer is really, really simple. As there's only one possibility in which a high can be formed with every I, and when the I acts as the low, and there's only one possibility in which the I and J doesn't form a high-low. All right, so I hope this video helps. Thank you so much for watching, and I'll see you tomorrow. All right, that was a problem review, and I know this is a really fun problem, and I hope you guys agrees too, because I love the problems when you just analyze a lot, like a lot. We analyze a lot, right? And we just basically write a very simple code. All right, that was the problem review, and now it's the grind report. Today I did not really do a lot, but you know, good enough. Good enough. I did the 2016. Where did 2016 go? 2016 U.S. Open contest. 2 problems from gold and 1 problem from platinum. Yesterday I did all 3 silver. Silvers are way too easy. I don't know why I did 2016 silver. There's just something wrong with me. And then I did 1 gold problem, which is the closing the farm yesterday. And today I did the other 2 gold, splitting the field, which is really easy, in which you literally split the field and find the answer for each field independently. And the other one is 248, which is a lot like 2048, except it's 248. And is a very, very basic interval DP. I think it's the first problem that I solved when I was learning interval DP. But yeah, I couldn't even solve it this time somehow on my own. So that's bad. But you know, after I looked at my solution last time, it was obvious. The solution became really obvious to me now. And now this is actual fun problem. This platinum problem is actually a lot of fun because is like binary lift. Is the final algorithm is a lot like the ST table RMQ problem using a binary lifting technique, but it doesn't look like that at all. Like you look at the problem and it really takes a lot of thinking, a lot of realization to finally realize that you can solve it using binary lifting, in which the complexity turns into 60n, because you notice that 262144 is 2 to the 18th and the range is 40, so the largest number you'll ever get to is 58, so it's 58 basically, or 60 times n. And that's for this platinum problem. And the 3 problems took me about 3 hours, and I had to use the solution on 2 of them. The third one, splitting a field, is way too easy. I'm not going to talk about it right now. I'll just do a really short problem review over someday. And that concludes the grind report for today. Thank you for watching. There's exactly 1 week from the 2024 January now. And I'm taking it on Monday, by the way. So yeah, this is quite disappointing because my progress is not as much as I want with only 1 week away, but that's all I can do. Thank you for watching.